Berkeley undergraduate. So who else here only has an undergraduate degree? Yes, okay, so a few of us diehards who learned computing in the trenches, or the gutter, as I like to say. So Berkeley undergrad, his first job was in 1967 for the Port Authority of New York. So, when you get off the bus and it smells kind of funny over there on the, that's what Don's, I don't know.
That was me.
No, that's Don. Worked there for a year before saying, the East Coast is kind of cold and want to come back to the Bay Area to his roots. Came back out here in '86, working for... 68. The year after I was born. Where he started working on RTOSs for IBM, including a supermarket project with Safeway. So back when real-time was actually real-time. After that, worked on MVS 370. So who's programmed in MVS? 370 architecture? Excellent. So hopefully we'll get a little war story action from those times. And in '78 started working on databases. And in '83, first release of DB2. Is that do I have the year right there, Don? Right. Absolutely. So he became at IBM the CTO for databases and content management, and in 2005 retired as an IBM Fellow. His picture is on the wall of IBM down at Almaden as one of the database gurus from one of the great database companies on the face of the planet. So with that introduction, let's hear what Don has to say about database land.
So in 1960, 65, when I was going 63, 62, there was no comp sci. There was a comp, but there was no comp sci. So there was we had one software course, non-credited when I left, which was in Fortran, and that was it. So that was the state of computer science in 1967, 66. So we're going to do a little, the story here is history repeats. So history repeats, remember that. And so every time that y'all come, you young folks come in to tell an old guy a story, and we go, I've seen that before. So this is I've seen that before, but that new thing is applicable now. And that's what we're going to get to, okay? So actually the trick in the CTO is, I've seen that before, but now's the time, and you guys got it, okay? So that's where we're going to go with this thing. So the basic architecture, we're going to start with a couple of observations, and the observation is the basic architecture today. So this is classic IBM or classic presentation. You give the end first, you give the story, and then you give the end. And it's to see if you're paying attention, okay? And we do that in IBM because the executives never get beyond the first chart. So you take the last chart, you move it first, because that's where you're asking for the money. So here's the punchline, give me the money, now here's the details. So that's the structure. So observation is that the basic architecture today, data architecture today, is federated. And you all know what that is, right? It's federated. And if I'd have said that like 30 years ago, everybody would have gone, no, it's monolithic. You have everything inside of your Oracle store. Today, forget it. It is federated. Number two observation is existing databases are good for doing existing stuff. They don't do new stuff well. They may do new stuff, they don't do new stuff well. If you really need it to be done well, you got to do something else. Why? Simple. They get bloat. I know, I've created lots of databases. They get bloat. It's kind of like me. You get bloat. And with bloat, you get complexity and you get commitment. The commitment is to a set of customers that you're going to be doing X for this customer and Y for that customer. And now you got a new one that you want to do Z, and it's not really compatible with the X and Y, so you kind of do a little bit of what Z needs to be done. And then you start to get bloat and complexity, okay. So eventually the old databases grow and try to satisfy some part of the market, but there's some catharsis that happens, some event that happens that demands something new. And we're going to go through a couple of those and to the present. Next observation is nothing ever goes away. Nothing ever dies. Okay? How many of you were doing computing in the 1970s? Oh, now raise your hand, because there's a couple of old farts in here that you must have been, okay, in the 1970s. So now the quiz is, there is a existing database that is used in the IRS that comes from the 1970s. What is the name of that database? Next. Next hint is, it didn't come from IBM. Model 204. Model 204 is an inverted file system that is still used for the core processing of your tax return. See, I'm getting one guy over here that he actually looks about my age, and he's going, oh my God. Nothing ever goes away, okay? Which is going to lead us to whatever choices you're making today, it is not going to go away. My brother worked for NASA, and the stuff that's up on the satellites that he created in the 1960s is still up in the satellites. Okay? So nothing goes away. I made some notes on my way here. The next observation is that new stores always start simple. So I'm going to give you some examples. So remember, I've given you the last chart first. Federated, old things do old things well, hard to make them do new things. And new things start simple. And they start with a KV, which is just CI-SAM renamed. So it's just an index store. And, or, a very shallow hierarchy. Everybody knows hierarchy? 2-level, everybody does 2-level, right? So you end up doing a 2-level hierarchy in there, which is Don, all the stuff related to Don. That's it, okay? So they start simple. And then they grow to satisfy another particular market. And that's what we're gonna go through because we're in a shift. There's a couple of shifts that's going on. Okay, those are they. Today, the new stores have to consume a lot. A lot. They have to be elastic. I know we overuse that one, but I'm going to tell you what elastic really means. And they have to do data discovery because a phenomena has happened over the last 50 years, which is we have slowly migrated to where the data that we have inside the enterprise was all internal. 50 years ago, 40 years ago, 30 years ago. It all came from inside. As we move through the 1990s and into 2000, the bulk of the data comes from outside. In the early part, back there, 50 years, 40 years, 30 years ago, we thought we could control it with a data model to guarantee what the data looked like. Now, on the IT side, we are simply reacting. We are reacting. And the database has to be part of that reaction. It is no longer a pre-planned event. It's what is going on right now and how do I consume it, integrate it in, and make it make sense. Okay, so time to consumption is everything. We saw that shift happen in the 1980s, but I'll get to there. So, this is a little history of the database. 1960s, database. How many were around in the 1960s? How many were even just around in the 1960s? Okay. How many were working in computing in the 1960s? The same? Oh, come on. I'm the only guy that was working in the thank you. Thank you very much. So in the 1960s, we had two database styles going on. It was just getting started. And this was Sabre, right, on the airline control system, and that was a KV store. That was just an index. stores. And we had IDMS and IMS, and these were hierarchical databases and network databases. And the way that reading the database started was because the hardware was so lousy, the disk would fail all the time. And so they were there to make sure that you could go and figure out what the data would really look like, because we were constantly recovering and restoring stuff. That's how we got started, was lousy disks. As opposed to today where we have lousy memory. So, lousy disks. And they were not generally available. In fact, if you looked around in companies at the end of the 1960s, you would have found about 6, 10 companies or so that you would have known about, other than military, that was using this sort of stuff. We used it in airline control, as I said, and we used it down in tracking auto parts for airlines. And that's where the hierarchical databases were used. Like I say, it was introduced into that time because we had these lousy disks and we had to timely get through some of this data. As we went into the 1970s, oh, by the way, our availability requirements in the 1960s was to try to stay up 8 hours a day, 5 days a week. That was our availability, okay? And there was a single application for the database. You did not have multiple applications for the database. There was an application for the database. We then move into the 1970s, and as we go through the 1970s, these hierarchical databases and the KB databases, KIT had one, which was file store, file control. They started to be used, but we're going to get to the end, because by the end of the 1980s, what percentage of the enterprises had even a single database in their entire shop? We're going to take a guess. What's your guess? What percentage?
End of the 80s?
End of the 80s.
30 to 50%, I guess.
30 to 50%, he's hedging his bets. Okay. What, you weren't there. What's your thoughts?
Like 50%.
50%. Do I have more than 50? 40.
4%.
4%.
5 to 10%.
5%. The answer was 25%. A quarter of the enterprise by the end of the 1970s had at least a database in their shop. This is 1970s. IDMS, IMS, hierarchical databases ruled the day. Application, database. Not two applications database, one application for the database. Otherwise things got all screwed up. By the end of the 1970s, availability requirements were 10 hours a day, 5, and maybe a half a day. Okay. So, it wasn't widespread. And developing an application, the key requirement as we came through the end of the 1970s, if I went around to 100 enterprises and I asked, what is it you want me to do? The answer was, I have a 2.5-year backlog on applications. Business, responding to my business. 2.5-year backlog, and I can't do it with that stuff. How do I get? And so you go 2.5 years. And it's growing. It's growing. So there'll be 3, 4, 5 years. In other words, they can't respond to their business. So meanwhile, relational technology started to pop up, right? It was invented, if you will, in the 1970s. And relational technology, database in a market, we were responding to two things. One is there was really no database in the Unix, and so Oracle went into Unix, which was used by engineers to track their stuff. And the second was the major enterprise, the parts of the enterprise which were not the engineering side of the enterprise, which were using, IBM stuff, HP stuff, and what those guys wanted, again, was something that was going to speed application development. At some price, it was going to end up costing them a little bit more. So DB2 came out, as did others, responding to that. And people go, oh, it was the relational model. No, it was not the relational model. What was it? Answer. So in the 1970s, to develop an application for IMS, for IDMS, you had to take the system offline, regen the database, reboot the database system, identify what applications you were to that database management system because they were not dynamically introduced. They were gemmed into the system. And then you brought it up and you tested it and it came down. Now, machines were very expensive. When do you think that we got machine shops? The answer was, some of you may remember that I said, requirements were up 10 hours a day, 5.5 days a week. And you might think, well, we got nighttime. No, nighttime was backing up the system. What we got was weekends. So we got one shot every weekend for a new application. Okay. How long do you think it's going to take you to work out your application? A very long time. So what happened with these new relational products that came out? You could dynamically create a database. You could dynamically introduce a new application without bringing the system down. This was like 100-fold increase. You could, I could give you a little testing thing, which you look today and go, well, that's not too innovative. This is 1970. This was very innovative, okay? So the point of that statement is, what are we trying to respond to with the technology? It's not about the technology, it's not about relational databases, it's what problem are we trying to solve for the customer? And the customer problem then was 2.5-year backlog. How do I make application development faster? So relational was terrific because I could show an executive. I could show an executive in business a select star from, and he went, I understand that. I could go and show an executive a network DPTG COBOL request, and he'd say, what is that? I don't even understand that. So right off the bat with the relational, he understood. Then I showed him that, by golly, we could make application development on the thing 100 times faster, but it was going to cost you 7 times more in compute cost. And he went, well, let's see, the employee suggestion program, that's probably a good one. I'll put that one in there. So something that has low volume, not used much, and I'll wait for Moore's law to catch up. And that's what happened. Okay? So here it is in the 1980s that we introduced relational database, targeting that. In the 1970s, if you wanted any information out of the database, you got a programmer. Okay? You got a programmer. It had to be programmed. Users didn't get access to the database. There were really, somebody will tell you there were BI tools. That's baloney. There were no BI tools, and the database wasn't understood. You had to get a programmer to program to it. Biggest godsend was 1972, when what came out? RPG, because that's what we created reports in. Okay, so y'all didn't touch the database, the data, store it all. You had to get a programmer to do it. So there we were in the 1980s, and the big opportunity was providing some tools so you could get access to the information. But remember, this is the 1980s. So, how many had parents in the 1980s? How many of your parents understood computing in the 1980s? 3, we got 3. Let's raise the hands again. How many had parents in the 1980s? You had no parents in the 1980s? Did you have parents in the 1980s?
My father died in 1983.
Oh, I'm sorry. How about your mother?
She was a kid.
Okay, so we had 3 hands come up to say that they understood it, and that's about the size of the thing. We didn't have an audience that understood computers, and we definitely didn't have tools that would allow that audience to look at it. It was programmed. So, while this relational thing came out, and we were all excited that it was addressing this backlog, remember, it was 7 to 10 times. I'm being really generous saying it was 7 times the cost because I did the DD too. And, you know, there were instances there where it's like 100 times the cost. But Vern Watts, he was the leader of IMS and he died, so I no longer have to respond to it. So meanwhile, this is important. While relational was taking off, there was a very special need that was going on. The banks of Japan wanted a database system, transactional system, that would run 24/7, never go down, and run like blazingly fast. Doesn't matter what we call blazingly fast. At that time, it was like 10 to 100 times whatever it is that you could buy on the street. And that's where IMS FastPass came. And so what was IMS FastPass? So here we have this flow going on of this relational thing, everybody's buying into relational, wrong. And we have this other need over here, which is really high performance of the 1980s, really high availability. And it's met by a offshoot coming out of the hierarchical database. And what was the structure of IMS FastPass? Remember, I started the whole thing and saying it always starts with 2 models. What are those 2 models? It always starts with a KV model. That's what IMS FastPass had. A KV model, simply an index on top of the thing. And it always starts with a shallow hierarchy, 2-level hierarchy. These were called DADBs. That's IMS FastPass. All the data was kept in memory as best we could, and we did group commit, which was like the novel thing in that time, and we could run blazingly fast. So while the rest of the world was looking at this relational stuff, you know, we had this other thing, which is this need for very high availability, very high performance that was going on, and we made a ton of money. And the banks of Japan were running on that stuff all the way through to when? Now. That is correct. That is correct. And it went down. The system went down for the first time about 3 years ago. For, I don't know, a couple hours, an hour or something like that. Front page news, and the CEO of IBM had to personally go over and apologize. Okay, so we have a major theme going on, which is relational database coming out to handle all this stuff over here, and we have this high performance, high availability thing. We're going to see that repeated again. In the 1980s, PCs started, but PCs were PCs. They were personal computers. People were getting into spreadsheets, but it wasn't like being used heavily inside of firms. It was private, it was personal. We didn't even, again, I asked how many people understood computing in the parents understood computing in the 1980s, and the answer is not many. You know, the guys that understood computing in the 1980s were like 15-year-olds and 25-year-olds. And they weren't doing spreadsheets in enterprises. But spreadsheets came. Notes came with email and handling stuff. Non-structured stuff. There is no non-structured stuff. It all has structure, but non-structured stuff. And what is the structure of a notes database? It's a shallow 2-level hierarchy. A parent and all the junk that you have, all the records associated with that. It's big table. Okay? So we had that, but if you looked inside the enterprise, we were doing email, but it was like casual communication, blah, 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 blah. That was a mistake. So what was happening on the business side in the 1980s was something called LBOs, leveraged buyouts. Everybody knows what a leveraged buyout is, right? What was happening was the guys inside the enterprise didn't understand what the value of their assets were. They weren't paying attention to their data that they had. The guys on the outside were paying attention to what is the value of this building? What is the value of that camera? What is the value of all the assets? And so they'd buy it and just sell all the stuff. It was a leveraged buyout. And so we had a whole bunch of companies that kind of, at that point went, we better get our arms around this data and understand what it is because we're at risk. We're at big risk. This was happening like crazy. Second event was going on, mergers. By this time we had a whole bunch of companies, enterprises, that were using computers to do their stuff. In the 1970s, if you went to the bank, there was a stack of paper at that bank that was listed your account. And if I went to my branch, he'd look it up and he'd figure out how much I had there, and she would write in what I was taking out and then give me the money. That was the 1970s. And if I went to a different branch, they'd call my branch and then somebody would do that. Towards the end, they were doing both. They were doing the computer and they were still writing on the paper. In the 1980s, they gave up the paper. Whoa. This was a big deal. So by the end of the 1980s, we had HR and we had all the basic business processes in most of the enterprises computerized. We now went through mergers. Oh my God, now I've got to get your HR system merged with my HR system, and your finance system merged with my finance system, and your merged with mine, and it was like a nightmare. Okay? Common parts list, blah, 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 blah. And so the answer at that point was, let's go and use just a couple of databases. Let's put everything into SAP. And then hopefully when we merge together, it'll make our life simpler. So is that what really happened? No, that's not what really happened. What really happened is the grunts had to go and provide bridges between all these things. We had to federate the stuff. And then try to smoosh it in eventually to get rid of the federation, but do we ever really get rid of anything? No, we don't. Okay, so by the end of the 1980s, number one requirement out of DB2 was availability. Stay up 24 hours a day by the end of 1980s. Stay up 24 hours a day. Why? Because they got rid of the paper. They got rid of the paper. Stay up 24 hours a day, 6 days a week. Not 7, 6 days. So we had 1 day to install software and do backups and all that sort of stuff. What do you mean? Doesn't the database run continuously without doing backups? Yeah, right. Okay. So that was the requirement. Except this extreme case, right, which I talked about, which is 24 by 7. Now we're going to put the next clicker in here. Worldwide. I want you up 24 by 7 worldwide. So now remember what networking technology looked like back around 1980s. Do you think there was just one instance of this thing running in Japan? No, there was an instance running here and this, and so you had this handoff going around the world, right? And that's where Tandem, et cetera, had great success. Great success. Handing off, copying, handing off, okay? To run a worldwide operation. Okay, so now we get into the 1990s, and people go, well, 1990s, that's internet. No, that's when the internet started. We saw starting of the internet when we were in the enterprise then. We didn't see people there doing all these internet-y things. We just saw them starting it, okay? So the dominant amount of data that we saw in the 1980s came from inside. Remember that, inside, because there's going to be a big shift here. As we went into the 1990s with the internet, by the way, I'm ignoring object databases because that would take me about a half an hour to tell you where they lived in this whole picture. So in the 1990s, internet's getting started. Now what percentage of the enterprise is using databases? 100. Not 90, 100. So by 1990, 100, okay, is using databases of some form. Transaction systems with databases underneath them. We get into them, but it's all internally driven data. Remember, I said the other problem was the levered buyout. People knew more about you than you knew about yourself. Started, we're going to get there. And companies that are in the internet space Amazon, Yahoo, Google, Google, something. They'll look around and say, what's the infrastructure? I mean, I need to do something here to run this stuff. And existing technology didn't work. They needed something elastic. What was elastic? And then we'll tell why they needed elastic. Elastic was that I needed to go from running one processor to 1,000 processors in 10 seconds. And why? Because the marketing model wasn't the old marketing model. Old marketing model at JCPenney's is, I go and I have this new piece of apparel. I try it over here in Dayton, Ohio. I see how it plays out in Dayton. I figure out how many I'm going to order. 3 months later, I move it over to Memphis, Tennessee. I work that one out. Now I do a worldwide rollout. What's the new model on in the internet? The new model on the internet is put it out, see if it sticks. See if they respond. It's now available to everybody. And then if it's not able to respond, how do you think the reaction is going to be of your customer set? You're down to two. You go to Amazon and the thing is down. Well, no, it has to expand, or it has to go from one processor to 1,000 processors in like that because you have a hot product. And you don't know it because you can't predict it. So the new market, the time to market model changed. And elastic was that capability. And then you had to have this other capability was, I just went like that, you had to shrink. Because suddenly at 10 o'clock at night it wasn't being used, but somebody else had, and you had to shrink. The second part of elasticity was, we now had new data coming from everywhere. Information coming from everywhere. It wasn't pre-planned, we didn't agree to what it looked like. You didn't talk to my DBAs and we get it all modeled and worked into the enterprise. It just showed up. It just showed up. And so we needed an elastic infrastructure to be able to handle an elastic data model, one that just showed up. Those were the two things that it responded to. So then we had one instance of one company that ended up taking Oracle and tried to glue a whole bunch of them together because it wasn't elastic in terms of being able to expand, so they had to build an infrastructure above that. We had another one which said, I'm going to go to start from scratch because that's not working out. I keep on fighting these guys. What was the data model that these guys were using that said we're going to start from scratch? KV and big table. KV, big table, right? An index on top, a little index database system, and a little shallow hierarchy. Here's all the stuff related to Don. It's all nearby one another. If the guy wants Don, he gets all the stuff related to Don. I hope that's what he wants. Because if he wants stuff related to, some cross-section of this, well, it's going to stink. But that's where we started. So while we had relational databases taking off like crazy, Oracle, DB2, Microsoft, the main thing, over here to the side was this new need for an elastic enterprise. Built on that data model. 24/7 worldwide. That's the requirement. No question about it. Application development time, now. That's the requirement. Meanwhile, IMS FastPath is going like crazy. TPF is running all the airline systems because it's tailored to that particular usage model. So you got this mainstream going on, and you got this high performance thing, and then eventually you've got this new structure in the enterprise, and that's where we are now, in the 2000s, right? So here we are in the 2000s, we've gone off to the cloud. The cloud could be private, it could be public, blah, 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 it's time sharing. We want to have access to computing resources from anywhere. And that's where we end up with these new databases. And that's the NoSQL, new SQL set. I'm not here hyping the thing. I got up this morning, I went for a 2-hour hike with my brother, who's 74. We had lunch. I met up with my, one of my grandkids and his friend. We went out, we did swimming in the pool, we played foosball. I'm set. I don't need this. Okay? Okay? I just came for the dinner. That's it. Okay? And that's likely all I'm to get out of these things is a dinner. So, but that's the new infrastructure. Highly elastic, so it's not just on the internet. I mean, look at JCPenney is the problem they have. Look at all, how fast time to market is everything now. Time to market is the winner. Is the best SSD ever gonna make it? No. What's gonna make it is the guy that gets there first and has a 3 months edge over anybody else. Time to market is everything. And that's what we have to respond to at the enterprise. At the enterprise is providing a infrastructure so they can get there now, time to market, no inhibitors, no 2.5-year backlog of application, now. So, that's where this stuff sets. So, out of that thing comes a structure. We talked about the fact that in the 1980s, the PC arrived, and we started to have tools that would allow somebody other than a professional programmer to access the thing. I don't mean a casual user, because in the 1980s, you know, anybody outside of Silicon Valley didn't understand how to use, you know, Macs or PCs very well. As we went in the 1990s, everybody knows how to use that stuff. So end user access to this stuff. We now have, how do I get analytics on all this information coming in from all these different places, where today it is the dominant information is coming from outside, not inside. DBA is not in control of the data model. He is reacting to the data model. It is coming in. And his job is to sort it out and try to figure out what makes sense after the fact. He's reacting. So you build a reactionary infrastructure, you introduce the stuff, and then I go and I tell you, you know that stuff you're getting off Wiki? It really stinks. Okay? That's my job as a DBA. Back in the 1980s, I said, I'm not going to make Wiki available to you until I guarantee it was all right. Now, I say, you're going to get it. Now I react to you getting it, and I figure out it's not all right, and you're building a business off of this thing, but it's reactionary. With we talk about the infrastructure, and the database infrastructure now has to expand to be able to take on the analytics of the enterprise. What does that mean? Remember back in the 1980s, we ended up putting out relational with a fixed set of functions, right? Do the sum, count, average, whatever. And then somewhere at the end of the 1980s, 1990s, we put in extensibility. You could provide your own function. Didn't really work out very well. What were some of the problems? Long talk. Didn't work out very well. We now move into where we are today. You've got to be able to make the database a platform play to be able to run the analytics of the enterprise. You have to be able to parallelize it. Hadoop, MapR, they're just another instance of this thing, which is a data store where they're able to parallelize it. Okay, so we've got this little thing going on here, which is I need a parallelization platform. These guys are introducing here UDFs. UDFs is a method of introducing application function into the database. But you have to parallelize this stuff, and there's a lot of work to be done there. But as we go through the next decade, the database becomes the platform for analytics, and it must incorporate your analytics. Not the ones I dream of, your analytics. It must parallelize it, and it must pipeline it. If it doesn't, the database just becomes a KV store. The platform for analytics is above. So that's where we are today. What happens as we go through the next, let's say 5, 6, 7 years? So in this world, the data, more data comes from outside than comes from inside. More data comes from outside than inside. We could probably find out more about you than you know about you. Which leads us all to concerns of privacy. Businesses only care a little bit about privacy. What they really care about is protection of their assets. That's what they really care about. Have they revealed assets? Who are the key players that are inside the firm that are going to get raided by somebody else? What is the real books? What's on the books for selling for the next quarter? What's going to happen over the next 3 quarters? Do you know more than they know? Very concerned with that. So it's really the protection of their asset. But suddenly we've opened this thing up, and everybody's getting helter-skelters going on everywhere. We're seeing that in securities industry, health industry, government, military, everywhere. So whereas it's opened up, how do we end up protecting, preventing, and then verifying it? Remember we said the wiki thing, right? How much of the wiki stuff is true? How much of the stuff that is coming over is true? How much of the stuff you read in emails is true? There you go. Responsibility of the IT shop DBAs is to guarantee, to provide some value of the assets there. And so we've opened it up, and this is a big can of worms right now for enterprises on the top. Okay? Protection of their assets. So, integrate, validate, verify. So, federation, complexity is rising, polynomial, I don't know, big. You know, a new data, you're all doing a new data store every year. You're all, every year, every day, you know, every minute. And I told you, Model 204 is still running as the base for our tax system. My brother's code is running up on some satellite. Okay? This stuff is going to be here forever. And we're making these decisions, so you have to choose well. Okay? So nothing goes away. So I started out in saying that the punchline is it's going to be a federated. Old things do old things very well. Oracle's not going away. DB2's not going away. It's going to do what it's doing, and it's going to do it very well. It's doing it well. IMS FastPass is doing well. What is the database system that's used for airlines? You're right, it's TPS. Okay? That's what's being used by them when you book something, okay? And Sabre. They're still using these same database systems. And I told you nothing's going away. New things, for new things that are really important. For new things that are important. And so the major little shift that we had is this shift to where agility, to be able to be elastic in our infrastructure, respond to the business now, and being able to react. And I need the data infrastructure to do that. And that's what those new guys are focusing on. Okay? So that's the shift that's happening now. I'm done.